Welcome to Study Loop.
Hello everyone, this is the solution to problem 39, chapter 24 of college physics. Here we're asked to find or come up with experiments that we can use to test if light from a given source is polarized or not. So I have as an initial setup here some kind of light source, and it's emitting light with intensity I sub I. And the simplest thing that you can do if you don't know if this is unpolarized or polarized vertically or at some angle is to get a set of Polaroid, or to get a polarizing material, and then you just look at the light source through that material. So what happens then is that you can measure the intensity of the light that's coming out of the polarizer. And if you see, for example, that the intensity falls to 0 at some angle, then you know that that angle is at 90 degrees with respect to the polarization of the light source, and you know that the light source is linearly polarized. So let's see, for example, if you had a light source that was vertically polarized, and you had placed this polarizer here such that its polarization axis would be vertical, so it would be like in this direction, then you would have a wave that's oscillating in this direction and propagating that way. And it's going through a polarizer whose frontal profile is blocking out things that are, or it's only allowing things through that are oscillating in this horizontal direction. Then the end result would be no light at all. So then you would know that the light source was polarized in the vertical direction. Now, on the other hand, if the light is unpolarized, then what you would see is that you would see some given intensity, which will actually turn out to be half of the initial intensity of the electromagnetic wave. And this would not change as you rotate this polarizer when you look at the light source through it. So you would always see a given intensity. Okay, so that's one way to do it. This is if you have access to a polarizer. If you don't have access to a polarizer, then since you can see the light source, or you can see the light coming from the source, that means that the source is emitting is emitting electromagnetic waves in the visible light part of or in the visible part of the spectrum. And so what you can do then is shine this source on a glass surface, for example, and then glass is going to polarize or is going to block out parts of the wave that are perpendicular to the surface of this glass. So, for example, you can see that the surface of this glass is in the direction of into and out of the whiteboard. So we have into and out of the whiteboard is parallel to this surface. And so what you can do is rotate the light source around in its position. And what would happen is you would see a maximum intensity in the reflected wave at some angle as you rotate through 360 degrees. And then you would know that it is in fact polarized, and is polarized in the direction perpendicular to the surface of the glass. So what I'm showing here is that you have the glass surface, and you also have an angle for the incidence of the light source that is 30 degrees. And I'm just using this because the angle, the Brewster angle for visible light is approximately 30 degrees, which means that the only component coming through is going to be the one that is at 30 degrees, or sorry, that is parallel to the glass surface. And so you can achieve maximum intensity of the light source just by looking at the reflection.